Hello, and welcome to Functional Skills Maths. Today's session is about the topic of BIDMAS. I'm just going to share my screen with you to get us going. Okay, so BIDMAS is about carrying out calculations in the right order. Now, the syllabus coverage is at both level 1 and level 2. At level 1, there are two things we're taking into account, which is calculating the squares of 1-digit and 2-digit numbers, and then following the order of precedence of operators. And then at level 2, the criteria is very similar, following the order of precedence of operators, but specifically this time including indices. So, what on earth is BIDMAS? We'll come to this in just a moment. But firstly, I'm just going to show you a sum on the screen. I'm going to ask you to write it down and think about your answer. Let me just give you a few seconds to think about this. Okay, so I wonder what answer you got. The actual answer is 2. But if you got 10 or -2, don't worry. These are very common answers to be given as well at this stage. We'll come back to this in a little bit and see how we arrived at the answer of 2. So, firstly, our aims for today are fourfold. The first one is to identify what the letters of BIDMAS stand for. Secondly, is to recognize and use the different symbols associated with indices. For example, 5 squared, 5 cubed, with a square root. Our third aim is to be able to work out the squares of double-digit numbers. And then fourthly and finally, putting all of this together and using the rules of BIDMAS to carry out calculations correctly. So, what on earth is BIDMAS? It's a funny word, it's a strange word, and it's an acronym. It's made up of the initial letters of 6 other words. Now, these are the words. The first one is brackets, that's where we get the B from. The second one is indices, which is things like your square number and your squared root. And then next we have the 4 major operations of mathematics. In order, we've got divide, multiply, add, and then subtract. Now, the word BIDMAS is in this order because it tells us that when we approach a sum or a calculation, we need to work out the various parts of that sum in this order. So if we see a set of brackets, for example, it means that even if the brackets are towards the end of the calculation, they need to be done first. So when we approach this sum here, our first one, 8 minus 3 times 2, the reason the answer is 2 is because using BIDMAS, we have to do the multiplication first. So 3 times 2, or 3 multiplied by 2, gives us 6. We can then feed that back into the sum. If we replace the 2 numbers that we've used to get our answer, if we replace that with the answer, then we have 8 minus 6, and that gives us the answer of 2. So it's all about doing things in the right order according to BIDMAS. Maths is its own language, and it's important to remember that because it means we don't always read from left to right when we do a calculation or a sum. In English, in the English language, we read from left to right. In other languages, they read from top to bottom. In some languages, they even read backwards. But in maths, we read according to the order of BIDMAS. So that's why the multiply comes before the subtract. Let's look at a few more examples and see if we can get the hang of this and put it into practice. So I've got the word BIDMAS for you up on the top of the screen, on the right-hand side, just for your reference. You may also have written it down, or you may want to take the time to do so now. What I'm going to do with the following examples is I'm going to give you about 10 seconds thinking time for each question, and then I'll run through the answer. However, if you would like more than 10 seconds thinking time per question, which many of you probably will, then please just press pause on your laptop or on your phone or whatever device you've got, and give yourself as much thinking time as you need. And then once you've got your answer, you can then press play again and we can work through the answer together. So the first one, I'm going to give you 10 seconds and see if you can find the answer here. Okay, your time starts now. Okay, so the first thing that we do here is divide, because it comes first in the order of BIDMAS. BID, so there are no brackets, there are no indices. Division is the first part of this that we do. So the division, 5 divided by 2 is 2.5. And then we can rewrite the calculation on the line beneath with our new answer, that new bit of information here. So 5 add 2.5 gives us 7.5. Let's look at example 3. So I'll give you 10 seconds and then we'll walk through it. Okay, so what are we doing first? Well, there's no brackets, there's no indices. We have got divide and we've got multiply. And according to BIDMAS, the D comes before the M. So divide needs to happen first before the multiply. So 12 divided by 2 gives us 6. And then 6 multiplied by 3 gives us 18. Let's look at example 4. I'll give you 10 seconds again. Okay, so we've got a subtract and we've got a multiply in the calculation here. Which one comes first? Well, according to BIDMAS, it's the multiply that comes first. So we do 2 times 7, first of all, giving us 14. We can then rewrite the calculation below with our new bit of information. So 21 subtract 14 gives us an answer of 7. Just as a bit of a tip, I would suggest rewriting the calculation on a new line every time you work out one part of the calculation. So for example, once you've worked out what one of the set of numbers is equivalent to, then just rewrite the calculation below, still working from left to right, but with that new bit of information, just so that it helps you to get the right order. 21 minus 14, and not, as you might be tempted to do, 14 minus 21. So rewriting it beneath helps us to keep it in the correct order still. Let's look at example 5. I'll give you 10 seconds. Okay, so we've got a multiply and a subtract. Multiply comes first. 2 times 6 is 12, and then minus the 8 gives us an answer of 4. Let's look at another couple of examples before we move on to thinking about the brackets. Example 6, a little bit more involved, this one, so we'll give you 10 seconds still, but press pause if you want to take a bit longer, which many of you will. Okay, So we've got three different operations here. We have multiply, we have add, and we have divide. Now, according to BIDMAS, we need to do the divide first of all, because it's first in the sequence. So the division is 20 divided by 4 gives us 5. So let's rewrite that on the line beneath. We now have 3 times 4 plus 5. So let's look at this line afresh. And we've got two operations now. We've got multiply and addition. Which one of those comes first? Well, going back to the word BIDMAS, we can see that the multiply, the M, comes before the A, which is the add. So therefore, it's the multiply that we do next. So 3 times 4 is 12. And then we can rewrite this once more on the line beneath. 12 add 5 equals 17. So working it through methodically every time, according to BIDMAS, helps us to ensure we get the right answer. Now, the reason why BIDMAS exists, you might be wondering, is because in any given situation, you might have a room of, say, I don't know, 50 mathematicians, and they all might be looking at a problem such as these, and different mathematicians might approach it in different ways. Some mathematicians might be from a country where we read left to right, and so they might want to do it left to right, and they come up with one answer. Other mathematicians might be from a country where they read right to left, and so they come up with a different answer. So the reason for the existence of BIDMAS is to establish an order that everyone in the mathematical community can use to ensure that there's always a consistency in our answers, and always we end up with the same answer. You can imagine, I suppose, what might happen if you've got two different rocket scientists working together on building a new rocket, and they're using two different laws of maths to work things out. You know, the sizes for the screws and the pistons or whatever might be very different, and so this rocket might not end up going anywhere. So by using one set system, or one order, or one pattern of doing things, we can ensure that there's a consistency and an accuracy in the way that we all approach maths problems. Okay, example 7. I'll give you 10 seconds again. Press pause if you like, and we'll walk through the answer shortly. Okay, so once again, there's 3 operations. We've got divide, subtract, and multiply. And the order, BIDMAS, divide comes first. So 150 divided by 3 is 50. And then we've got 2 operations left, subtract and multiply. Multiply comes next, according to BIDMAS. 5 times 4 is 20. Rewrite the sum beneath. 50 minus 20 gives us 30. Okay, let's look at this example here. This was from my Facebook page not so long ago. They tend to come up from time to time and do the rounds. But you can see there on the top of the screen, 10 minus 10 times 10 plus 10 equals, and then below in the feed, you can see already from the first couple of answers there, we've already got quite a range of answers. Some people say 10, some people say 20, one person says it's 0, somebody says minus 100, somebody else says minus 80. So what is the correct answer? One of those answers on the screen is correct, but which one? Let me just rewrite the sum again for you here so it's a little bit clearer. Now, again, I'll give you 10 seconds, but press pause if you need to. I certainly needed a bit longer than 10 seconds when I was just double checking this. But see if you can work out the right answer. I will walk through it shortly. Okay, so what do we do first? Well, according to, we've got 3 operations: subtract, multiply, and add. According to BIDMAS, it's the multiply that comes first. So that means right here in the middle is where we start. 10 times 10, which gives us 100. And if we rewrite the sum beneath, we have now got two operations left. We've got 10 minus 100 plus 10. So again, looking at BIDMAS, what comes next? Is it the subtract or the add? And it's the add. So we do 100 plus 10, which gives us 110. We now rewrite that one more time, and our final calculation or final sum becomes 10 minus 110, which gives us minus 100. So, looking at the list of answers on the screen, who is correct? It's this fella here, Brent. Well done, Brent. Okay. So we're now going to look at a few examples where we start to introduce the brackets. And now remember, with the word BIDMAS, B comes first. So the brackets will always be first. So let's have a look at this one. I'll give you 10 seconds. You can start now. Okay, so what we do using BIDMAS is we look at the brackets first. So 12 minus 7, that's inside the brackets. So let's work that bit out. 12 minus 7 is 5. We can then rewrite the sum beneath, and we have 5 times 5 divided by 5 for our second line. Still using BIDMAS, we've got to do the division next. So 5 divided by 5 gives us 1. We can rewrite the sum on the line beneath, and we end with 5 times 1 is equal to 5. Okay, so let's have a look at another example. I'll give you 10 seconds again, and we'll walk through together afterwards. Okay, so let's look at the brackets first, because we've got some there. So 14 minus 2 is 12. Rewriting the sum beneath, we've now got two operations left, which is the add and multiply. Multiply comes first. So 2 times 12 is 24. And then rewriting that on the line beneath, 4 add 24 gives us 28. Very good. Okay, one more example here before we start to look at indices. So I'll give you 10 seconds again, and then we'll walk through it. Okay, so using BIDMAS, we can see that the brackets are going to be the first thing that we do. So 30 minus 2 gives us 28. We can rewrite the sum with a new bit of information on the next line. We've now got two operations to choose between. These are divide and multiply. Divide comes first, according to BIDMAS. So 20 divided by 5 is 4. And then we have 4 times 28 gives us 112. Okay, so we're now going to spend a bit of time thinking about indices and the various indices that we can have in a question. So the most common ones are whether we square something, as in the first case there, 5 with a little 2. That little 2 means that we've got to square it. It's now a squared number, 5 squared. Or the other most common one really is to find the square root of something, which is kind of the opposite, as we shall see. So when we square a number, firstly, it means that we multiply it by itself. For example, 3 squared means 3 times 3. 5 squared means 5 times 5. 8 squared means 8 times 8, and so on. So when we're squaring a number, we're simply timesing it by itself. Now, it's really helpful to be able to square single-digit numbers quickly. The quicker you can do this, the more time it's going to save you in an exam. So I've got the numbers here from 1 to 10, just written out with the little squared symbol next to them. Now, I wonder whether you can go through and sort of work out reasonably quickly what the answers to each one of these is. So let me give you 10 seconds again. Press pause if you need to, as I suspect you probably will, and see how many of these you can complete. Okay, your time starts now. Okay, so 1 squared. This one can be slightly tricky actually, but 1 times 1 is 1. 2 squared. 2 times 2 is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared, 81. And finally, 10 squared is 100. So if you're not sure of these, I would strongly recommend that you write them down on a bit of paper, perhaps on some flashcards or revision cards. Look at them time and time again and commit them to memory. Perhaps ask a friend to help test you throughout the day, just to ask you maybe on your break times or your lunch times, or perhaps when you go home, if you've got somebody at home, you can maybe ask them to help you to learn some of these. And who knows, if you're sort of, motivated by kind of food treats as rewards, then perhaps you could give yourself a Mars bar for everyone that you get right, or maybe that might be a bit too much. Perhaps a Smartie or something that might be more proportionate. But anyway, whatever works for you. But if you can remember these, that'll be really helpful for the exams, just to get you through some of the questions a little bit quicker. Okay, now the square numbers 1 to 10 are great. They're very helpful to remember. But what happens if we end up with double-digit numbers? Well, yes, we could use a calculator if we are on the calculator section. However, it's worth noting that BIDMAS normally comes on the non-calculator section of the exam. And so we need a way of working out square numbers without using a calculator. The examiners certainly don't expect you to remember all of the square numbers beyond 10 all the way up to, let's say, 99. They're not expecting that at all. Rarely, actually, does an exam go above 25 on a square number question for BIDMAS. However, we need to establish a method for working them out without a calculator. So what we're going to do is play a little bit of a noughts and crosses game. Not exactly, but we're going to start there. It's going to look like a noughts and crosses game when we first start anyway. So the first thing that we do to work out an example like this, 17 squared, is we draw a grid. Ta-da! And there is our noughts and crosses grid. What we can do, just for reference, is put the 17 into the top left-hand corner as a reminder of what we're trying to find. If you're trying to find a different number, then obviously you can put that number there rather than 17. What we then do is break that number into tens and units. And so 17, we can say, consists of 10 and 7. So we can pop the 10 into the middle column at the top, and we can pop the 7 into the final column at the top. So we've now got column headings of the 10 and the 7. We're also going to do the same for the row headings, actually. So the 10 and the 7 are also going to go on the left-hand column beneath the 17 to make row headings as well. So we've now filled in most of this grid already. And we've scarcely done anything other than break the number down into tens and units. What we do next is the bit where we start to work towards the answer. So we've got to multiply across. So in this middle box, we're going to put the answer to 10 times by 10. The answer to that, of course, as we've seen, is 100. So the 100 goes in this middle box. We'll then carry on across the row, and we'll multiply again with the 10 over on the left-hand column, 10 times 7, which is at the top here. And 10 times 7 is 70. We pop the answer there. And we can now work down to the bottom row and do the similar thing. So look at the row heading on the left, it's 7. We multiply that by the column heading, which is 10. So 7 times 10 is 70. What you might notice, actually, every time you do this, on the diagonal, you will always have the same answer appearing twice. And then in the final box on the bottom right-hand corner, this is where we do the single-digit multiplication. And so this was the page we looked at earlier. It's very useful if you can do those single-digit square numbers fairly quickly, because it helps you with this grid as well. So we do 7 times 7, which is 49. And with that, we've completed our noughts and crosses grid. What we now do is, with the 4 numbers we've just worked out, we add them all together, and that gives us the answer. So in this case, it's 100 plus 70 plus another 70 plus 49 comes to 289. And so the answer to the question 17 squared is 289. Okay, hopefully that's clear. If not, feel free to press rewind on the video and watch through again. What we're going to look at now is 3 more examples, and I'm just going to give you 10 seconds again. Obviously, it's going to take a little bit longer than 10 seconds. So just press pause on your video, work out the answers to these 3 questions on the screen. And when you've got your 3 answers, press play again, and we'll just see what the answers are. Okay, so your time starts now. Okay, so that's your time. So how did you do? Well, the answer to 18 squared is 324. The answer to 22 squared is 484. And the answer to 25 squared is 625. Okay, if you got those right, well done. And if not, then have another go. Just look back at the method, look back at the previous example if you need to, work through that grid again and see what went right and see what didn't go so right. You know, maths is all about having a go, really. And if it didn't go right, then which bit was it that didn't go right? Just try and find that little bit, because it may be that you got most of the question right and there was just one of your answers may have been slightly off. So please do work back through those if you've not got them right this time, and see if you can suss them out. Okay. We're now going to look at the square root of a number. So this is another type of indices symbol that might appear in a BIDMAS question. That's the square root. So there we have the square root symbol, and it's just in front of the number 9. So what we're asking is, what is the square root of 9? Now, the square root is essentially asking what number multiplied by itself gives me 9. We've got a couple of other examples here. The square root of 25, what number multiplied by itself gives me 25? And finally, what number multiplied by itself gives me 100? And so it's a bit like the opposite of finding out the squared number of something. Let me show you what I mean. So the square root of 9 is 3. Now, you may remember from our previous screen that when we square the number 3, we end up with 9. So 3 squared is 9, which means The opposite is true. The square root of 9 is 3. Let's try 25. What is the square root of 25? Well, it's 5, because 5 times 5 gives us 25. And so the square root of 25 is 5. And you may remember that 5 squared gives us 25. And so there's that relationship there between the square root and the number itself squared. Let's look at the final example. What is the square root of 100? Well, what number times by itself gives me 100? And the answer to that, of course, is 10. So 10 is the square root of 100. Okay, so most of the ones, if they appear on the exam paper, will be fairly recognizable to us if they're asking us for the square root of things. It's very unusual that they give a sort of a double-digit one, to be honest. But let's maybe look at a few other examples just to see how we might approach these things if they do come up. Square root of 81. Well, this is still a single-digit number, and you may recognize it again from earlier on. Square root of 81 is, of course, 9, because 9 times 9 is 81. And then what is the square root of 144? Well, the square root of 144 is 12. 12 times 12 gives us 144. And then the final one there, square root of 225. With something like this, it may require a little bit of trial and error, a bit of educated guesswork. So we can see already that it's going to be bigger than 12, because 12 times 12 gives 144. So it's going to be a little bit bigger than that. But it's probably not going to be as big as something like 20, because 20 times 20 would give us 400. So we know it's somewhere between 12 and 20. And probably more towards the 12 side. So we could just guess maybe 14 or 15. So we can just try that out on paper. We can use our grid method to put those ideas into practice. So if we adopted the number 15 as our guess point, we could do 15, use the noughts and crosses grid to work out exactly what 15 squared is. And we will see, in fact, that 15 is the correct answer for this. The square root of 225 is 15, and 15 squared, if we use that noughts and crosses grid, would give us 225. So a little bit of trial and error, a bit of educated guesswork can help there. Yeah, okay, let's have a look at the final type of indices that may come up, and that's to do with powers. Now, what we mean by this is those little numbers that we saw earlier for when we square a number, it doesn't always have to be a 2. See, when it's a 2, it is a power, but it's specifically called squared, 5 squared, 3 squared, 8 squared, whatever it is. But it can also be a 3, for example, very common if we're working with volume calculations. When we cube a number, if we're trying to work out the amount of cubics air, for instance, that's in a room, or the cubic liters in a swimming pool. But we can also carry on increasing beyond that. And by that point, they're just called powers, really. So 5, let's just work through a couple. So 5 squared, we know, is 5 times 5, and that would give us 25. 5 cubed, or 5 to the power of 3, means 5 times 5 times 5, which would equal 125. And one more example. 5 to the power of 4 means 5 times 5 times 5 times 5, which would give us 625. So whatever the little number is, tells us how many times to write the main number, and then all we do is put the multiply symbol in between them. So let's look at this example of 5 to the power of 4, and we'll see that if we take care of the first one, 5 times 5 is 25. So we can cross out those two. 5 times 5 is 25, like so. And then we do the next bit along. 25 times 5, we'll get rid of that. And that would now give me an answer of 125. And then finally, we've got 125 times the 5 gives us our answer of 625. So that's how we work through a powers question. Let's have a look at a few examples. I'm going to give you, well, I'm going to pause again for 10 seconds. So hit pause on your screens. Try and work out these three problems here. We've got 4 to the power of 3, 8 to the power of 4, and 7 to the power of 5. Okay, I'm going to pause for 10 seconds from now. Okay, so how did you do? It might be surprising, some of the size of these numbers, but 4 to the power of 3 is 64. 8 to the power of 4 is 4,096. And 7 to the power of 5 is 16,807. So if you got those right, well done. And if not, then just have another look back through those and see if you can work it out. Press pause on this screen here if it helps, so you can see how many times to write out the numbers. And you can work it through. You're welcome to use a calculator just to check that these things are right. Or other than that, you can use long multiplication, which we can discuss in another session. Or you can use a little bit of addition if you prefer that way of working out your overall answers. Okay, so now we've looked at indices in a bit more detail. We're going to return to some BIDMAS questions where we're going to pop some of these back in now and make the BIDMAS questions a little bit more complicated. So, example 11. Once again, I'm going to give you the 10 seconds after it appears on the screen. You can press pause and work through at your own pace. Press play when you're ready to walk through the answer with me. So there we go, 10 seconds starts now. Okay, so as ever, it's the brackets first. 6 divided by 2 is 3. Let's rewrite that on the next line. We've got 5 squared times 4 plus 3. So indices now come into play, and these are the square numbers. So 5 squared is the next thing we have to work out, and that of course is 25. 25 times 4 plus 3 is the next line. We've now got to choose between multiply and add. Multiply is of course next in sequence. So 25 times 4 is 100, plus the 3 gives us 103. Okay, let's look at our next example. Okay, 10 seconds starts now. Okay, so what do we have here? We have no brackets this time. So indices are the very first thing that we need to work out. So 3 squared is of course 9. So let's now rewrite the sum beneath. We've taken care of what the indices mean. So the value is 9. We've now got 3 operations: divide, add, multiply. Divide is next. 3 divided by 2 is 15. We've got add and multiply. Multiply is the next one in sequence. So 3 times 9 is 27. 15 plus 27 gives us 42. Okay, so look at our next example. Example 13. 10 seconds starts now. Okay, so what have we got here? Well, we've got some brackets, so they need to be done first. Even though the indices are there, what this means is that because they're on the outside of the brackets, we have to still work out the inside of the brackets first, and then we can apply the indices afterwards. So 15 divided by 3 is the brackets. The answer is 5, and then the indices are now on the outside. So 5 squared is what we've now got to work out, along with this other one, 7 squared. So you can do these at the same time, or one by one. So 7 squared is 49, 5 squared is 25. Rewrite the sum beneath. 49 times 3 minus 25 leaves us with a choice of 2 operations next, which is multiply or subtract. It is, of course, multiply. So 49 times 3 is 147, minus the 25 gives us an answer of 122. Okay, if you need to pause on this one to just think about some of those things, then please do. Otherwise, we're going to move on to example 14. So, 10 seconds again, starting now. Okay, so what have we got here? We've got brackets, which of course need to be done first, but within the brackets, we've got an indices noted. So, that's the square root of 25 plus 2. So what do we need to do first? Well, we have to do the indices which are inside the brackets first, because without working out that, we can't actually work out what the brackets are. So the square root of 25 is 5. So we can now rewrite that again beneath if we wish. And we can now see what the brackets are going to be quite easily. 5 plus 2 is going to give us 7. But we can also work out this indices over here if you like. So I'm just doing both of these at the same time to fit them on the screen, to be perfectly honest. So 6 cubed and 5 plus 2. So 6 to the power of 3, 6 times 6 times 6 is 216. 5 plus the 2 is the 7. And so when I rewrite it on the line beneath, I've now got 216 times 2 minus 7. Out of these two, multiply is of course next. So 216 times 2 is 432. Subtract the 7 gives us an answer of 425. Okay. Hopefully that's clear. If not, then just do feel free to have another look back through that one. And then one more example that we'll walk through together before I give you a couple to just think about. So, example 15, we've got a question written a bit like this. So it's written differently here. What we've got is some numbers on top of the line, and then obviously some numbers beneath. That line in the middle means divide. So what we have to do here, because it's written in this way, not in the ordinary way, what it means is that we have to work out what's on top of the line first, and then divide it by whatever is on the bottom of the line. So that's just a slight adjustment to the division within BIDMAS. Normally, it's as we've done all session, just worked it through, divide first. However, when a divide symbol is written in this manner, it means that you have to work out what's on top before you can then divide by whatever is underneath. So I'll give you 10 seconds again, have a think about that, and then we'll walk through it. Okay, so 3 to the power of 5 minus square root of 9. So 3 to the power of 5 is 243, minus the square root of 9, which is 3. And then we write that over the square root of 64. So 243 minus 3 is 240. And that is again written over the square root of 64, whatever that is at this stage. The square root of 64 is 8. So our final part of the sum is 240 divided by 8, which gives us an answer of 30. So it's just a little bit of a different look or layout to the way that a BIDMAS question can be put. Okay, all right. Here are 5 questions for further practice. I'm going to pause the screen again for 10 seconds. You'll need to press pause even just to write out one of these, let alone work them out, I'm sure. So please do press pause and try and work through each one of these and get your answer before you walk through the answers or before you look at the answers, which are going to appear on screen shortly with me. So 10 seconds starts now. Okay, so you've probably put in a bit of blood, sweat, and tears there to sort of work these out. if you've not just skipped through anyway. And so we'll just look at the answers now. And they are answer one, or to the first question here, is 169. The next answer is 15. The answer to question 18 is 161. 106 is the next answer, and the final question there, the answer would be 132. If you got all of those right, give yourself a pat on the back and a chocolate brownie or something like that. You've done really well. Hopefully you found that really helpful, and certainly if you've got this far, you've done really well to hang in there with me. So what you could do now is have a go at making up some of your own BIDMAS questions. And if you've got a friend who's on the course perhaps, or somebody in your household or a family who knows how to work through BIDMAS, then you could set them the questions that you make for a bit of a challenge. And I would say, try and use at least one indice per question. Make it a little bit complicated for them. But do, of course, make sure that you work out the answer for yourselves using the BIDMAS method. And it'd be really interesting, actually, for you to send those questions to either myself or to your tutor, just so that they can see how you're applying your understanding and putting it into practice. So yeah, please do have a go at that. Write out 3 BIDMAS questions and show the workings with your answers as well. And so your tutor can have a look at those. Okay, well done, well done. So in summary, what we've looked at in this session is we've identified what the letters of BIDMAS stand for. And we now know that it's brackets, indices, divide, multiply, add, and subtract. And what it means is that we always have to work through calculations in that order. The second thing we've looked at in quite some detail was recognizing and being able to use and calculate with the different symbols associated with indices. For example, 5 squared, 5 to the power of 3, to the power of 4, and so on, and the square root of numbers. We've also looked at a method for how to work out the squares of double-digit numbers, for instance, 17 squared, without a calculator, by using that noughts and crosses grid. And then finally, we put all of that together and used BIDMAS to carry out calculations in the correct order, so that we can have the right answers every time. Well done. Thank you for being with me today on this session. It is a really important session, and it's really crucial that you can have a good understanding of this, because it is a little bit of a foundational principle of maths and math calculations that we are using BIDMAS in the order that we do things. Yeah, if you need to revisit this, then of course, please feel free just to watch through the video again, or talk to your tutor if you wish to discuss it any further. But for now, thank you for staying with me, and take care, and I wish you all the best in your math studies.